We have Newton's law problem types, which involves the application of Newton's laws and is best illustrated by examining some typical problem situations and their solution. What we have here is a lift problem with an accelerating frame of reference. Question reads, a man of mass 60 kg is inside a lift. What is the force the floor of the lift exerts on the man when the lift is stationary? When it's moving upwards at a constant velocity, it's moving upwards in an acceleration of 1 meters per second squared. What we can do is we can draw the diagram of the lift and the man inside the lift. So we have this and the man inside the lift, and we want to look at what are the forces acting on the man. So we draw a free body diagram of the man. Now take note that there are no horizontal forces, there are only vertical forces. One is the weight and the other is the force of the lift, or the force the ground exerts on the man. Let's call it force lift. Now with these two forces, remember the man is inside the lift, so whatever happens to the lift, whether if it's stationary or it's moving upwards with a constant velocity, or if it's accelerating, the man has to follow suit. Now these two forces should actually give you a resultant force that allows the man to move accordingly. And if you look at scenario 1, when the lift is stationary, that means the acceleration is 0. And therefore, the resultant of these two forces, the force upwards minus the force downwards, the resultant force should be 0. That makes the force of the lift equal to the weight, which equals to mg, and you have 60 times, you take g to be 9.81, and you work it out to 2sf, you get 590 Newton. So you have this answer here. The force the floor of the lift exerts on the man here is equal to the weight of the man, 590 Newton. Now if you look at the second scenario, moving upwards with constant velocity. So the term constant velocity tells you that again the acceleration is 0, and what we can safely say is that again the force of the lift minus W, the net force is 0, which gives you the force of the lift equals to the weight again, and that equals to 590 newtons. So for scenario 1 and 2, the force the floor exerts on the man is the same as the weight of the man. Now when it goes to part 3, that's when it becomes a bit interesting, when the lift starts to accelerate upwards. When the lift starts to accelerate upwards, then we have a slightly different situation. The man himself needs to accelerate upwards. And for the man to accelerate upwards, we need to have a situation where this force would be much greater, because you need a net force upwards as well. And if you look at the scenario, say, make this smaller, and we look at this scenario now, you want to force the lift minus the weight goes to ma, and you know that the acceleration now is 1 meters per second squared upwards. So the force of the lift is equals to the weight plus, and you have 590 plus 60, which gives you 650 Newton. So in this case it's 650 Newton. So what you want to take note is, when the lift accelerates upwards, the force the floor of the lift exerts on the man is much higher than the weight, and that is the sensation that you feel when you actually move on a lift which is ascending upward. The sense that you feel heavier is actually due to this, right? So I hope this makes it clear, and we can follow up with further questions on Newton's laws. Thank you.